Okay, so in week 8, we're talking about functions, and so we're just getting used to some new vocabulary. Here's our example. A function is going to have some graph, so this could be the temperature as a function of season or something like that. When we talk about where is the function increasing, we're talking about uphill. So imagine that you're going left to right, just like when you read and you're traveling along a roller coaster like this. Okay, increasing means you're going uphill, decreasing means you're going downhill. So we could highlight these sections maybe like this. The increasing parts would be uphill like that, and then uphill like that. So increasing, and then the decreasing parts, that's pretty downhill to me, and that looks pretty downhill to me, decreasing. So take a look at how I have, I'll zoom in a little bit, take a look at how I have written this, and this is inequality notation. So for the first increasing part, this is x equals -2, this is x equals -1. When we talk about where or location, we're talking about x coordinates. So x is between, so it's greater than -2 and less than -1 right here. And from here we're going from x equals 1 to x equals 6. So x is greater than 1 and less than 6. Notice how this is not or equal to. At the top, when it's flat, we can actually say that it's increasing at that point. Or down here, it's flat momentarily. We cannot say that it is increasing at that point. So, there's another way to write this, and that is like this. So that's inequality notation. Let's see. Okay. We can also use what is known as interval notation. So between -2 and 1, we can just say -2, comma, -1, and comma. We have another interval, and that is from 1 to 6. So from 1 to 6, like that. So this is another way of writing that. We call this inequality notation, and we call this interval notation. And so similarly for where it is decreasing, we could, I'm going to use a different color, we could say from -1 to 1, and again those are x values. I know it's kind of weird because it looks like the coordinates of a point. And then we can say from 6 to 8. Okay, interval notation. Sometimes you'll see like a U in between these for union, meaning and. Okay, local maximum and local minimum. So by local, we mean basically in the graph that you can see, not way off at infinity or something like that. So for maximum and minimum, we look at the graph, and what we can see, we see this is the lowest point. So for our local minimum, that would be at x equals 2. So we could say something like at x, that's an x, equals 2. We could also list the coordinates of the point. That's not 2, that's 1. Shame on me. Okay, we could say at x equals 1. We could also list the coordinates of the point and the coordinates of that point. The local minimum are x equals 1 and y equals -2. For the local maxima, meaning there are 2 of them, so that point is taller than the points around it. And this point is also taller, or has a greater value than the points around it. So for the local maximum, we can say there's a local maximum at x equals -1, and also at x equals 6. So there are 2 local maximums, or 2 local maxima. The graph, here's what I mean by local. The graph keeps going like this. So way off at -infinity, we'd have, or at -1,000,000, we'd have a very large negative value. But when we talk about local, we're just talking about in the stuff that we can see, basically. Okay, and then what else do we need to talk about? The zeros and x-intercepts. So I'm over here. Zeros, x-intercepts, those are basically, those are synonymous. So that would be this point and this point. So we could say x equals 0 and x equals 4. So notice how the y-coordinate is 0. Those are x-intercepts. Y-intercept is also this point here. So we could say at y equals 0. Sometimes they're the same, sometimes, most times not. And for domain, so let's see. I can't remember what my graph looked like, but I think it just looked like, dang it. Okay, if the graph had arrows, because I just covered it up, if the graph had arrows, it indicates that it keeps going down and right and keeps going down and left. If they were just solid dots, it means it kind of stops here. So I'll pay more attention on the next graph, but assuming that there were arrows, we could say the domain goes from negative infinity to positive infinity, meaning all real numbers. The range, so we're talking about the possible y values, the tallest this graph goes is up to 5, but then it keeps going downward. So for the range, we could say something like y is less than or equal to 5, because the y values, the graph keeps going down, but it doesn't get taller or higher than y equals 5, it looks like. And then here, this notation, f of 5 equals what? That says, in other words, what is the value of the function at x equals 5? Meaning, at x equals 5, what is the height of the graph? So at x equals 5, what is the height of the graph? Well, that's at y equals 2. So we could say that is 2. All right, that's related to the inequality and interval notation. So let's, oh man, we don't want that. All right, we're going to leave that here. Okay, for this next question, it says use Desmos to graph the function. So in that, in the first example, the graph is given to us, but here the graph is not. So we're going to use Desmos to actually graph this, and we're going to get something that looks like this. Let's see, where can I get that? Well, here. So we're going to get something that looks like this. So let's pay attention to this 6, negative 108 as our local minimum. And then we can hopefully get this thing out of here, because it's pretty annoying. And then maybe, okay, so those got stuck there. Here's what the graph should look like, all right? So we have it we have that it increases, and then it decreases, and then it increases. We're interested in this point, that's what I just showed you, at x equals 6, and then this point at x equals 0. So it looks like it's increasing from all the way from negative infinity to 0. So we could write that as this, from negative, why do I keep drawing an 8? From negative infinity to 0, and then union or comma. It's also increasing after x equals 6. So that would be 6 to positive infinity, not 8. If we were writing that in inequality notation, it would look something like this. X is less than 0, and x is greater than 6. Notice how I did not use or equal to, because it's not increasing at those points. Okay, and then it's decreasing between 0 and 6. So for our decreasing, we could say between 0 and 6, so x is greater than 0 and less than 6. In interval notation, we could say that. Alright, so there's our increasing and decreasing information. You could write that in there. Local maximum and local minimum if you're looking at your graph, the local minimum, what was that, at 6, negative 108, I hope. And that's the thing that I threw away over there. And the local maximum was at 0, 0. So I'm listing coordinates of points. I could also say it's at x equals 0 and it's at x equals 6. The domain, so this function basically goes like this, meaning it keeps going down and left, and it keeps going up and right. So the domain is going to be all real numbers. It doesn't stop going to the right, and it doesn't stop going to the left. The range as well is going to be all real numbers because it doesn't stop going up, and it doesn't stop going down anywhere. X-intercept and y-intercept, let's see if we can look back at our graph. So it looks like the x-intercept and y-intercept in this example as well end up being, so we could say x equals 0 and we could say y equals 0. We could also list the coordinates of the points, which is the same, it's just the origin in this example. And then, ooh, this is a good question. Is there an absolute maximum or minimum? And what that means is there some value that's the largest value that it ever attains? And the answer is no, because it keeps going up and right and it keeps going down and left. If we were looking at our previous example, and I don't think I had an absolute maximum or minimum listed, but in this case we do have an absolute max because there's no value on the function that is larger than that. It doesn't keep going up in any direction, so it would be an absolute as well as local because it's right here and we can see it. But whatever that was, 1, 2, 3, 4, 5, maybe it was at 6, I forget. Okay, that's pretty sloppy, sorry. And f of 1 equals what? So this graph is way too messy to look at that, but if you have your Desmos pulled up, you can actually tap on it and it will show you the coordinates of the points. But we can also say, well, here's our function, so what it's asking us is y equals 0 cubed minus, f of 1, I'm sorry. Totally slipping today. Y equals 1 cubed minus 9 times 1 squared. So that would be 1 minus 9, which would be negative 8. Okay, so I'm worried that I'm going to run out of time here. Plus this is so convoluted. So what I'd like you to do, I think you can do the second page. So just, yeah, I'm going to stop this video. Go ahead, do the second page, and then I'll have some answers posted in another video. Thanks.